Hey everybody, Mr. Grove here. We're going to talk a little bit more about significant figures today. And so we know significant figures help determine the accuracy with which a number was measured. So if we were measuring the meters it takes from here to Taco Bell, and we found that to be 9,200, if we had this number here, 9,200 with no decimal point, with just 2 sig figs, as opposed to this number here, 9,200.00, with 6 significant figures. So if we were looking in like a journal or a lab report, this number here would tell us that, that was a ballpark. It was rounded off. It could be anywhere from 9,201 to like 9,049 to 9,249. There's lots of kind of discrepancy possibility there, which just tells us that measurement didn't have to be terribly accurate. But if we saw this in part of the lab report, so then we would see 9,200.00, we know that that number is accurate all the way out to the centimeter standpoint, so tenths, hundredths of a meter. So we would have to be accurate to a centimeter's distance worth from here to Taco Bell, all 9,200 meters exactly. If we're doing the lab, this is going to be significantly less detailed and costly. I mean, we could probably just step it off. Whereas if this was what we're after, we know that we would have to recreate that lab with a very accurate measuring system to get down to that level of accuracy. So that's kind of the gist of sig figs, as to kind of why we do them, to give you, the reader, an idea on how detailed the number needs to be whenever you're recreating it or measuring it. Moving on now, as we go into simple calculations with sig figs, we'll do multiplication and division first. And so basically, you're going to multiply out your number as usual. So in this case, 23.5 times 10, and we got to do the math correctly. So we would get 235, and then we would figure out how many sig figs to round to. So in this case, multiplication and division, your answer can only have the number of significant figures as the smallest sig fig number in the calculation. So what we mean by smallest is how many significant figures. So 23.5 had 3. We learned that from the last lesson. And then 10, with no decimal points in there, only has 1 sig fig. So our answer then basically has to be rounded to 1 significant figure. So as we round that, we would get an answer of 200. That would round all the way down to that. And that might seem like a big round to us, but the reality is that just tells us, the reader of this lab investigation, that we don't have to invest a lot of time or energy into making that number all that accurate. So it's how many sig figs are in the calculation. So if we have 14.0 divided by 22, so 14.0 would have 3 sig figs, 22 would have 2 sig figs. So we got to do the number right, and so don't be that guy or gal that punches the wrong buttons, gets the wrong answer that way. But once we get the right number, then we have to round to the appropriate sig figs. So we have all these decimal points here, but we don't have to. I mean, that would be an incredible amount of instrumentation to carry out that detailed of number. Our 3 sig figs here, 2 sig figs here, our answer only needs 2 sig figs. So what we would do then is just round this to 2 sig figs. So in this case, that would be 0.636 would just round to 0.64. So that would be our answer. Sorry for the sloppy there. So 0.64. Next, we would have 325 times 0.05. Do the math. We come up with 16.25. And now we have to round appropriately. So 3 sig figs 2 sig figs. So our answer can only have 2 sig figs. So in this case, we would round that to 16. Okay, so that would be our rounded answer then. And then the last example we got here for multiplication and division. So 1.575, divide that by 0.21. So we get 7.5. That's the number that comes out. And then 4 sig figs, 2 sig figs. So our answer can only have 2 sig figs. So our rounded answer would actually still just be 7.5. Okay, and so that is multiplication and division. If we switch to addition and subtraction, the rules are a little bit different. It doesn't matter how many sig figs are in the numbers. It matters more on place holding. So again, we have to do the math right. So 254 plus 15.25. So punching that through, we get 269.25. And then our place holding is going to be rounded based on where that was at. So if we know that this 254 was significant to the 1 spot, 15.25 is significant to the 100th spot. So our answer gets rounded off at the 1 spot, and so we would have to round that down to 269. Okay, so that would be our answer there. So it's a placeholding thing, not an amount. So if we have 3,000 minus 158, so punch it through, we get 2842. But again, it's going to be a sig figs positional thing. Well, 3,000 is only significant to the 1,000 mark. So that means my answer is significant to the 1,000 marks. So as we're rounding, looky here, so that's 2842. That actually rounds back up. So our sig fig answer would be 3,000. Okay, so we'd round that up, which seems weird. But that just tells us this is a really estimated answer. We don't have to put a lot of time and effort into the actual measurement of this volume or length or whatever it was. One last one, 12.3575 plus 0.50. So this one is significant all the way out here to like the 10,000ths. This one's only significant. The 0 does count, so it's significant to the hundredths. So our answer is going to be significant to the hundredths as well. So we would round that to 12.86. Okay, and so that's going to be our answer. So that's simple addition, subtraction, multiplication, and division on sig figs. And hopefully that will help as you do your practice on those, and we'll see you next time.